Hi, this is Jennifer Brazier, and let's talk about Lewis structures. So, your teacher may have had you make some Lewis structures where you look for electrons that can be shared between two atoms. And whenever you circle two electrons and share them, you drew a line. Well, that method of drawing Lewis structures is great. It gets the point across. It's understandable. However, circling electron pairs from individual atoms doesn't work for drawing all Lewis structures. There are some, like Lewis structures that involve the noble gases. We're trying to find electrons that don't have partners and then sharing electrons. Well, that just doesn't seem to work. So we need a different method. So what I'm going to show you is 5 steps. You want to go ahead and follow these 5 steps in order. And if you follow these 5 steps in order, you should be able to go ahead and draw any Lewis structure that you want. So let's begin. Step 1 of drawing any Lewis structure is you need to go ahead and add up the valence electrons from all the atoms within the molecule. So when you go ahead and look at those valence electrons, remember they're the same as the main group number. So group 1A, the hydrogen, lithium, sodium, all of those atoms have 1 valence electron. Group 2A, starting with beryllium, 2 valence electrons for that family. We're going to go ahead and skip those transition metals right now, and let's go to group 3A, starting with boron and down. That family, they all share 3 valence electrons. The carbon family has 4 valence electrons. The nitrogen family has 5 valence electrons. The oxygen family, group 6A, 6 valence electrons. The halogens, 7 valence electrons. And finally, the noble gases have 8 valence electrons. You want to go ahead and add up the valence electrons for all the atoms within your molecule. That's step 1. Now, step 2 says, put the least electronegative atom that isn't hydrogen. You can't put hydrogen in the middle. Hydrogen only ever gets 1 bond. So take the least electronegative atom that isn't hydrogen and put it in the middle. Now, I'll tell you a secret. You actually don't probably need to sit there and look at an electronegativity table and go, let me calculate who's the least electronegative. It's almost always going to be the different atom. So if you have CCl4, there's 4 chlorines, 1 carbon, put carbon in the middle. PCl3, 3 chlorines, 1 phosphorus, put P in the middle. Put the one that's a solo in the middle. Another tip for you, carbon makes a great metal. If given the choice, put carbon in the middle. Carbon always makes 4 bonds, so it can be completely surrounded on all sides by atoms. So never hydrogen. Carbon's a great metal, and it's usually the one that's not like the others, the different one. All right, step 1, add up the valence electrons. Step 2, put the different one, not hydrogen, in the middle. Step 3, you want to fill in the octets, 8, of the outer atoms. So the atoms that are circling your center, you want to make sure all of the sides are filled up. So we're going to sprinkle lone pairs of electrons around those outer atoms such that each of those atoms will have 8 total electrons around it, except for hydrogen again. Remember, hydrogen, good with 1 bond. It's a baby. It's our tiniest little atom. So that hydrogen only ever gets 2 electrons around it or 1 bond. But everything else, let's fill up those outer octets. Step 1, add up your valence electrons. Step 2, put the different one in the middle. Step 3, fill up the outer octets. Step 4, if you have any leftover electrons, you're going to keep this running total going. If at this point you have any leftovers, put them on your center atom as a lone pair. Not separate, not individual electrons, but just put them as a pair of electrons around your center. Now, then and only then do we do step 5. Sometimes my students get into trouble because they want to rush things. They want to start making multiple bonds, double bonds, triple bonds on everything. No, we only do step 5 when it gets to step 5. So step 5 says when you've completed the other steps, check, does your center, or in fact any other atom that should have an octet, does your center have an octet? If it does not have an octet and it should have 8 electrons around it, what we need to do is we need to make multiple bonds. We need to make either double bonds or triple bonds. So the way that we're going to do that, we're going to swipe electrons away from the electron-rich atoms that are on the outside, and we're not going to give them to our center. We're not going to give them to the electron-poor atoms, but we're going to share with the electron-poor atoms. We're going to swipe and share to make those multiple bonds until that center, those atoms that should have an octet, they indeed do have an octet. So make sure you follow steps 1 through 5 in order. And if you do that, you should end up with an awesome Lewis structure. I hope that helps. Take care.